Welcome to Homework Lib.
Hi, so over here we're going to have an analytical chemist that is titrating 101.9 milliliters of a 0.21 molar solution of nitrous acid with a 0.85 molar solution of potassium hydroxide. We want to calculate the value for the pH after the addition of 27.44 mole of potassium hydroxide, and we're given the information that the pK of nitrous acid is equal to 3.35. So let's calculate the amount of mole initially present in solution. So for HNO2, the amount of mole that we're going to have is going to be equal to the volume in liters times the concentration in molarity. In this case, it would be 0.1019 liters multiplied by 0.21 mole per liter. In this case, I'm going to omit the other zeros. Let's remember in this case that we're going to give our answer up to four to do decimal places. Okay, so 0.1019 times 0.21 gives us 0.021399 mole. On the other hand, the amount of mole of potassium hydroxide that we have added after 27.44 milliliters have been added is going to be equal to converting the volume into liters and multiplying by the concentration of 0.800 mole per liter, we're going to get 0.023324 mole. That means that in our reaction we're beyond the equivalence point, that we have converted all HNO2 into NO2 minus, and additionally to that, we're going to have an excess of OH minus in solution. For that reason, the pH is going to be given by the excess of hydroxide that we have added into solution, and the amount of excess is going to be equal to the amount of OH minus added minus the amount of HNO2 that we had. In this case, it would be equal to 1.925 times 10 to the minus 3 mole. And what is going to be the total volume? Well, the total volume would be equal to the sum of the both volumes that we are going to have. It's going to be 109.9 milliliters plus 27.44 milliliters, which is going to give us 129.34 milliliters, or which is the same, 0.12934 liters. Thus, the concentration of OH minus that we're going to have in solution is going to be equal to 1.925 times 10 to the minus 3 over 0.12934 liters. This is mole per liter, which gives us 0.01488 molar, 8832 molar, just to keep all of the values until the end. We can calculate now the POH, which is minus the logarithm of the concentration of OH minus, which is going to give us 1.883, and pH is going to be equal to 14 minus POH, which gives us 12.17. And this would be the pH for our solution. And with that, it would be all. Notice that in this case, we didn't require the value for the pK of nitrous acid because we are beyond the equivalence point. That means that we have already added more of the potassium hydroxide that was required for the titration. Thus, the pH is given by the excess of hydroxide, as I mentioned at the beginning. And with that, it would be all. Thank you very much and have a good one.